Hello, today we have this baby reading and real analysis problem. As always, I have a very consistent upload schedule. So we have A and B that are separated subsets of Rk. With the elements of A and B, we have this function that looks like linear interpolation. The argument is a real number. Have inverse images. So we have three statements to prove. For the first one, we have to prove that A0 and B0 are separated subsets of real numbers. So it's fairly easy to show that A and B do not share any elements. However, they may still share a limit point, so we have to show that they do not. So how do we do that? Well, the way to go is to show that the limit points of A0 are gonna be, well, when you insert them into the function P of that limit point is gonna be a limit point of A, and a similar thing for B0, so let's go ahead and do that. Let's say we have limit point L, and for every radius greater than 0, there exists Q, such that Q minus L is less than that radius. Now if we were to check the distance between PQ and PL, well, we're working with the RK, so it's gonna be this. Next, we can just directly find the points. It's gonna be 1 minus QA minus 1 minus L, A plus QB minus LB. Next, that's gonna be 1 minus 1 is gonna be 0 minus, okay, L minus Q times A plus QB minus LB, that's gonna be Q minus L times B. Alright, now we can factorize this stuff. Of L minus Q times A minus B. So in the end, what we have is minus Q times the distance between A and B. Alright. Now let's pick for every let's say R2 greater than 0, exists alright, let's look into this. L minus Q times L minus Q times A comma B less than R2. Then next we're gonna do is L minus Q is gonna be less than R2 over D A comma B. Alright. Exists Q that belongs to A0 such that G P Q P L is less than R2 And well, L minus Q gonna be less than 2 over DAB. Alright. Now, if we were to look into that, we precisely got a limit point, so P of L is the limit point of A, yeah? Now, if L was the limit point of A0 and B0, then P of L would be a limit point of A and B, which would be a contradiction, because A and B are separated. So the first one done. Let's go to the next one. So we were to look into points. The cases are it's either point of neither A nor B, if we were to look into those cases, then we have a closure of A, closure of B, and we're to look into that, then okay, for one, what we're looking for is just T of 0 that belongs to 0 and 1, and T of 0 must belong to neither A0 nor B0. Now we were to look into A0 and B0, and then the closure of A0 intersected with B0 is going to be the empty set, and similar case, intersection of A0 with the closure of B0 to be an empty set. So for one, the intersection between A0 and B0 is an empty set. Therefore, there exists an element X that does not belong to A0 or B0. Alright. Now, that being said, the only way for this to be true is if from 0 to 1 it's entirely occupied by either A0 or B0, which is not the case, because if we were to plug in 1, it's going to be B. If we were to plug in 0, it's going to be A, yeah? So we're to look into the number line, have 0, we have 1. Here it's going to be just A, there's going to be B. Alright, now, that being said, there must exist at least a single element that does not belong to A0 or B0. Now, it could be a limit point, but if there isn't one, then every element belongs to either A0 or B0. And now the thing is, there needs to be some intersection point where here we have B0, here we have A0, and this strip here exists. How do we deal with it? Well, there are two ways to go about this. One, it could be a limit point of A0 and B0. And well, as we have proven already, A0 and B0 are separated, so it can be a limit point of both. So instead, that can be the case, and those are supposed to be separated by a gap like this one. I know it's very unrigorous, but I can't really paint a lot of stuff in Paint, and I also have really little time right now on my hand. I have to literally speedrun this. Alright, C. Prove that every convex subset of RK is connected. Well, it's a direct consequence of A and B. Thinking about this is the fact that, well, preconvex subset over K is gonna be connected because no matter what 2 points we pick, if the subsets are separated, then P of T is gonna form 2 separated subsets. So yeah, the only way for it to be convex is for it to be connected. I'm not gonna write it down for the most part. Actually, no, let me do it actually. Let me just resort to this rend purely for no reason. Okay, x and y belong to K, yeah? Must belong to K2. Now let's say K is not connected. Let's say x belongs to K1, y belongs to K1, K2. K1 and K2 are separated, so 1 minus t x plus y is gonna form K1 0 and K2 0. Those are gonna be separated. And another thing is that there's gonna be a point where 1 minus t x plus y does not belong to K1 0 or K2 0. Therefore, okay, no, did an oopsie. For t is gonna be separated, alright, and there's gonna be a t. Let's call it t0 that does not belong to K1 0 or K2 0, and P of t0 will not belong to K1 or K2. Therefore, P of t0 does not belong to K. Right, this was very unrigorous, I know. I have very little time on my hand right now, which is also why I have so little videos lately. That's it for today. Bye.